Exponential functions, part 2. First, we're going to evaluate some values in your calculator. So you're going to do 5 to the 2.5 power. You may want to use parentheses on these exponents. When you get your answer, we're going to then round it to 3 decimal places. So I will just write down what I have. I have for this one 55.9017. We want to round to 3 decimal places, which will be here. You look one to the right, the 7 is going to push us up. So rounded, it is going to be 55.902. 3 to the square root of 5 power. Right, so first I get 11.66475. We want to go to 3 decimal places, which will be here. Look one to the right. The 7 is going to push us up. So we're going to have 11.665. Then we have e to the 1.2 power. And you should have an e button on your calculator. So first I get 3.3201. We're going to go to 3 decimal places, which will be here. You look one to the right. A 1 is not enough to push us up, so we're just going to drop the 1 off. To 3 places would be 3.320. Next, we have some applications of exponential functions, and we're going to calculate some compound interest. Compound interest means you earn interest on top of your interest, right? And so after t years, the balance in the account will be the A with principal P. This is what you put in originally. Annual interest rate R, which is in a decimal form, so drop your percent 2 places to the left, is given by these formulas. T is your time in years. N is your compounding intervals. For the second formula, this one compounds continuously. It uses our E for a base, and the exponent is the rate times the time. So your rate would again be as a decimal. Your time is in years. For your compounding intervals for the N, semi-annually means N equals 2. That's twice a year. Quarterly means N equals 4, which is 4 times a year. And monthly, N equals 12. We're going to look at some problems. We're going to first find the accumulated value to the nearest cent of an investment of $25,000 for 7 years at an interest rate of 5%, and we'll look at various compounding intervals. So first we're going to look if it's compounded semi-annually. So we're going to use our first formula, A equals P times 1 plus R over N to the NT. You're going to plug in, we're looking for accumulated rate, so that we don't know. P is your 25,000, what you're putting in originally. Keep your parentheses, 1 plus. Change your rate to a decimal, 0.05, divided by N, your compounding intervals. Semi-annually is twice a year. So N is equal to 2. Close your parentheses. You have your N again, 2 times the number of years, which this one is going to be 7 years. And then you're going to go to your calculator. You still have to watch out for order of operations. Just to be safe, I would go ahead and do 2 times 7 is going to be 14. All right, keep that in mind. And I would start within the parentheses. I would do the fraction first. Those of you who are really clever with the use of parentheses, you could use parentheses twice here and not have to do your fraction first. But I would do my fraction first. 0.05 divided by 2. Get an answer, add 1. Right? Then you have to raise it to the power. So then I would raise my answer to the 14th power. Then I would multiply times 25,000. And what I get is 35324.35. And I have already rounded to the nearest cent. Next, we're going to compound quarterly. So the same amount. So we want to know the accumulated amount. We're putting in 25,000. Keep your 1 plus your rate is 0.05. Right? We're compounding quarterly. That is 4 times a year. So our n is 4. Our exponent is going to be 4 times t, which is 7 years. So this time when we work it out, we'll go ahead and do the 4 times 7 is 28. Keep that in mind. Inside your parentheses, do 0.05 divided by 4 plus 1. Get the answer. Raise it to the 28th power. Then multiply your answer by 25,000. This time I kept it without rounding so we can talk about the rounding. So I have 35399.807. And it keeps going, but we would just want to go to the nearest cent. The cent is the hundredths place. You look one to the right, the 7 is going to push it up. So we're going to be 35399.81. Next, we're going to compound monthly on the same problem. So our principal is still the same, 25,000. Our rate is 0.05. Our compounding intervals, if it's going to do monthly, will be 12. Our exponent will be 12 times 7. And we can go ahead and figure that out. 12 times 7 is 84. So we're ready to go into our calculator. 0.05 divided by 12. Add 1. Get your answer, raise it to the 84th power, or if you didn't figure that out, raise it to a power and use parentheses. Do 12 times 7 and close the parentheses. Right. Get your answer times 25,000, and I have 35450.901. We're going to the nearest cent. So the 0 is in the cent place. The 1 will drop off. It's not enough. So we have $35,450.90. For our next one, we're going to compound continuously. So this means we have to use the second formula. A equals P times E to the RT power. So our A will still be our accumulated rate, 25,000 for our principal. E is our base, and we're going to do our rate, 0.05 times our time, which is 7. So we're going to the calculator from here. It might be hard to remember a decimal, so you might want to use parentheses this time. So I want my E button, and on some calculators, remember it's above your button. So do what you need to get the base of E. Raise it to the power. Use parentheses, 0.05 times 7, close the parentheses, get your answer, times 25,000. And I get 3,5,4,7,6.688. We're going to go to the nearest cent. So this is the cent place. This time we're going to go up. So we have 3,5,4,7,6.69. So we'll just compare these values for a minute. So semi-annually, compounding, quarterly, monthly, and your highest one is the continuously. For our next problem, we're going to create a general formula for $14,000 at 8% compounded quarterly, and we're going to leave t in as a variable. So we'll plug in everything we know. So A equals our 14,000, that's going to stay constant, times 1 plus, our rate is 8%, 0.08. Our compounding intervals in quarterly is 4 to the 4 times t. So what we want to do is just do all the math that we can. What we can do is we can work inside the parentheses. So we're going to keep our 14,000 and our value inside the parentheses is going to be 1.02. So in your calculator, 0.08 divided by 4 plus 1 gives us 1.02 to the 4t power. So we can plug in different t's into this formula and get an answer out. We have one more problem to do, and this one also asks us to write a general formula. You have $12,000 to invest in a bank that pays 7.2% interest compounded monthly. Use the formula for compound interest to write a function for the balance in the bank at any time t. Right, so we're going to use the same formula. A, this time our P will be 12,000. Parentheses 1 plus, your rate is 7.2%. Drop your percent, move your decimal 2 places to the left. So 0.072. Your N, it's compounded monthly, so it's going to be 12. And your N will also be up here, 12 times T. So we want to work out the value that's in the parentheses. Put it in your calculator, 0.072 divided by 12 plus 1, and I get for that 1.006 to the 12t times 12,000. So that is our general formula, and then we could use that for different values of t. Just a couple of quick examples. If I let t equal 1, so that was our answer. If I let t equal 1, so it stayed in for 1 year, then I'm just going to do 1.006 to the 12th power, because 12 times 1 is 12, times 12,000. My answer would be 12,893.09. And I'll give you one more, and you can check it on your calculator. If we let t equal 5, use the same formula, except we're going to put a 5 here. So 12 times 5 is 60. So you're going to do 1.006 to the 60th power times 12,000, and the answer I get is 17,181.45 4, 6. The important thing about getting a general formula, if you were going to have to do a bunch of values, you could use a spreadsheet, put the formula in one time, and then put different t values and calculate it. So just an idea there.